In this video, I will talk about overlapping of deformer bar of river steel. So at first we have to understand what is the lapping zone. Actually, lapping zone is that zone where we as usually can overlap safely. So that is why we say to avoid tension zone to provide lapping and provide at compression zone. So we have to understand what is the tension zone. Suppose if we assume a vertical member, say it is a column, so we have to find the clear spacing in between beam bottom to slab top. Then if we divide 4 times, if we divide with 4, then middle 2 part of this clear spacing is known as compressive zone, and near to the beam support is known as tension zone. So say beam bottom to slab top is 8 feet, then middle 4 feet is allowable lapping zone, and near to the beam support 2 feet, bottom of the beam and top of the slab is known as tension zone, or we should avoid that zone for lapping. We have talked about the vertical member. Now let's talk about the horizontal member. Suppose this is a simply supported beam. So this beam stands on 2 supports. So as we know, if we provide imposed load on this beam, so here compressive pressure acting at the middle of the beam at top, and tension is acting at the bottom of the beam at middle. Similarly, at support, from bottom to top, the compressive strain is acting on the support, and top to top at support acting as tension. So we can say what is the tension zone. The bottom layer of the middle section of horizontal member and the supporting and the top layer of supporting zone is known as tension zone. So we have to avoid this tension zone for provide lapping. Okay, say if we talk about slab, so slab, there this is top layer and this is bottom layer. So we have to avoid near to the column or beam support for top layer, and we have to avoid middle section, middle zone of the bottom layer of reinforcement to provide lapping. So where we can safely overlap at horizontal member, for top layer we can provide overlap at the middle, and for bottom layer we can safely overlap at near to the column support. This is safe zone for overlapping, and we have to understand that we can't overlap cutted bar. We will provide lap at straight bar. Okay, and 2 more fundamental, that we should not provide overlap at the same height. We should alternate this. Okay, now if we talk about the lapping length, before talking about lapping length, one more fundamental thing, that please provide lapping inside of the member, whatever it is, vertical member or horizontal member. So if we talk about lapping length, as per thumb's rules, practically we use these rules. We know the overlapping and compression zone is 40 times D. Somewhere we use 50 times D also. And at tension zone it is 60 times D. So what is 60 times D or 50 times D? Let's see in example. If we assume as tension zone, then 60 times D, 60 times D means diameter of deformer bar. Suppose we are using 20 mm diameter bar, so 60 into 20, 1200 mm. So it is 47 inch lapping length. But in BNBC, Bangladesh National Building Code 2020, and ACI code also says that lapping length at compression zone should have a same as the development length, and in tension zone should have a 1.3 times of development length. So what is development length formula? Development length is proportional to yield strength divided by root over the strength of concrete and diabar of steel. So if we provide constant of this proportional, we get this formula. So if we apply magnitude on this formula, suppose we are assuming yield strength is 500 megapascal, concrete strength is 20 megapascal, and diabar is 20 mm. So if we assume this magnitude and if we apply this magnitude on the formula, we will get 80 inch at compression zone. So development length is 80 inch. So lapping length also it is 80 inch. And for tension zone, 1.3 times of development length, that is 104 inch. So it's too much higher. This is 102 times D at compression zone and 132 times D at tension zone. It's too high. But don't worry, in Asia, IS code, Indian code also says that development length is equal to diabar into stress in bar divided by 4 times design bond stress of concrete. So same if we apply the same magnitude in this formula, we'll get answer. Development length is 1133 mm at tension zone, that is 44.6 inch, and 906 mm, that is 35.7 inch. So what formula we should follow? Before describe this, I would like to explain in a formula. This is Excel sheet. Suppose diameter is 20 mm, concrete grade is 20, steel grade is 500. This is ACI or BNBC formula RAP, and this is IS formula RAP. So according to BNBC formula, lapping length in compression zone is 80 inch, whereas if we assume thumbs rules 50 times D is 39 inch. But IS code says is 35.67 inch, whereas 50 times D is passed. Similarly, if we apply the BNBC code at tension zone, so it's 104 inch, whereas thumbs rule says 47 inch. But according to IS code, it's 44.6 inches. So also thumbs rules has passed. So what formula should we follow? My opinion is, if we are building as usual structure or not high-rise building, suppose it's 2-story building or 3-story or up to 4-story building, we can use thumbs rules as usually. But if we are designing irregular structure or very high-rise building, then we should follow ACI or BNBC code. Number one point. Point number two, if we are constructing at earthquake possible, higher possible location, then obviously we should follow BNBC or ACI code at that situation. Then you can say that this is too much costly, so you can convert into coupler, then the cost could have been reduced. If you would like to interest about the coupler formula, then please comment below. I will explain in another video about the coupler lapping. Thank you very much for watching this video. Goodbye.